Breaking, this just in. Studies show that merely a devastating 4% of the population know about how CDs function. Don't worry because we have you covered. For you to understand, let's first go over waves and light theory. First up is waves. A wave can be thought of as a disturbance that travels through a medium. It has a wavelength, which is the distance between two successive crests or throws, and a frequency, which is the number of wavelengths that pass in a second. Now that you have an idea about waves, let's talk about interference. There are two kinds, constructive and destructive interference. When two waves come close to one another, their effects add together. If the crests of two waves line up, then the combined wave will be the sum of the heights of the two original crests. The same applies for throws and their depth. This is called constructive interference. Destructive interference occurs when two waves are not perfectly aligned. So when the crest of one wave comes, it will be dragged down by the throw of the other, and vice versa. Lastly, let me tell you about resonance. Resonance describes the phenomenon of increased amplitude that happens when the frequency of a force on an object is in tune with the natural oscillation frequency of that object, otherwise known as that object's resonant frequency. And now, I'll hand it over to Stefan, who will explain to you lasers and geometric optics.
Thank you, Azan. Here at Blaze Compacting, the theoretical principles of light and optics are applied to make CD-DVD players. In the earlier days, data such as music was stored on vinyl records. This method relied on turntables with moving arms that bounced along grooves in the plastic. The problem with this was that over time, these records would scratch easily, which corrupted the data. This type of mechanical technology is a thing of the past. Nowadays, with the invention of CDs, data can be collected using optics. More specifically, laser light is used to record and read information from metal-coated discs. There is no physical contact with the metal. The only thing that touches the CD is the beam of light from the laser that bounces harmlessly off the CD. The usage of laser light also allows for fast retrieval of data, since a CD player can quickly position the laser to point to any part of the disc. Let's take a closer look at the workings of a CD player, more specifically the laser device. Inside your CD player, there is a miniature laser beam called a semiconductor diode laser. This is a powerful laser about the size of a simple lead. In the diode, there is something called a PN junction that consists of two slices of material, one known as a P-type, the other known as a N-type. These materials are made from an alloy of aluminium and gallium arsenide. The P-type section slightly lacks electrons, has more holes in the material, while the N-type section has slightly too many electrons. Putting these sections together is what makes the PN junction. The PN junction allows electric current to flow in one direction from the N-type to the P-type section. As electrons flow, they combine with the holes on the P-type, which gives out energy in the form of photons. These photons bounce rapidly back and forth in the microscopic junction between the P-type and N-type semiconductors. This amplified laser light then emerges from a polished end of the diode through a lens, projecting onto the CD to read data. This data is interpreted from the inner workings of the CD disc. My co-worker, Daniel, will explore this topic further.
Thanks, Stefan. Let's take a deeper look at what a compact disc is on the inside, and how it's read for information. A CD is actually just a metal sheet with grooves spiraling all the way through it. This metal sheet is sandwiched between two layers of plastic. What's interesting is the grooves in the metal are actually bumpy. The sequences of lands and pits along the grooves is what conveys information. In binary, a pit is seen like a 1 and a land is a 0. So how does a pit get read by a CD player? Well, the disc is rotated inside the CD player with a laser along the grooves. If the laser hits a pit, the angle will be just right to shine into a photocell that interprets the light as a 1. The lack of light is interpreted as a 0. This process is essentially how we can extract info from a disc. Right before we let you go, here's Layla with some expansion on disc technology.
Thanks, Daniel, for those insightful words on how CDs process binary data. Now that we understand that, can we apply this understanding to how DVDs and Blu-rays work? Absolutely. And the main difference between these optical discs is how much they can each store, which ultimately depends on the pit sizes as well as the type of lasers that they use. So when we look at Blu-ray discs, for example, we see that they have the smallest pit size amongst all of the optical discs, meaning that they have the ability to store the most amount of binary data. Additionally, they use blue light lasers, which have a much smaller wavelength than red light lasers, meaning that they will be a lot more precise and have the possibility to read the small pits, allowing the Blu-ray discs to have the most amount of storage amongst all of the optical discs. It's super cool to see how all of these work, and it's so exciting to wait for what the next generation optical disc will be like. Now I'd like to pass it back to Azan.
Thanks, Layla. Hopefully you viewers out there now understand how CDs work. From everyone here at Waterloo News Network, both on camera and behind the scenes, we thank you for tuning in and have a good night.